All right, folks, so what we're going to do now is we're going to do some examples. We're going to wrap together all of our understanding of the graphs of logarithmic functions to identify the base, the reflection, the vertical shift, horizontal shift. What I have here for you is another procedure. You can write these straight out. First thing you're going to do when identifying the function of a logarithmic graph is you're going to draw in the vertical asymptote. Then you're going to plot the point on the curve, and it's going to be 1 unit left or right from the asymptote. Then identify the base, and we know how to do that. We want to go 1 unit up or down from where the point is, and then measure the distance between the curve and the asymptote. Then we're going to identify the left or the right shift, and remember that's based on whether how far the vertical asymptote is from the y-axis. How far has the vertical asymptote shifted to the left or to the right? We're going to put that shift with the x in the parentheses, and we're going to have the opposite sign. So if it's a +7 shift, we'll put a -7 with the x. Okay. Then we're going to identify the vertical shift, up or down shift, that's based on how far the point is up or down from the x-axis. We're going to put that on the end of the function as a plus or a minus. And then the last thing we're going to do is we're just going to look at the reflection, whether it's upside down or backwards, and put negatives on the front or inside with the x. Now remember, if it's a backwards and it has a horizontal shift, you're going to need an extra set of parentheses. Here's what I mean by that. Let's say that it's backwards. Let's say we have f of x is equal to, let's say the base is, 3, log base 3, and it's backwards, but it does not have a horizontal shift. Well, in that case, you can just put negative x. Okay? This is fine. You don't need extra parentheses if there is no horizontal shift. But if there's a horizontal shift, if it's like a leftward shift by 8, so it's a -8 shift, I'll put the negative, then I have to put an extra parenthesis and put x plus 8. The plus 8 represents the -8 shift, and then I need an extra parenthesis here. Okay? So you only need the extra parentheses if you have a horizontal shift. But if you do not have a horizontal shift, you do not need the extra parenthesis. Okay? All right, so let's go ahead and do a few examples here. Let me clean this up a little better. There we go. And we'll project an example or two up onto the board. All right, so we have, here's an example. We're just going to follow the step-by-step procedure, one thing at a time. Step 1, draw in the asymptote. We can see that it goes perfectly vertical right here. It becomes a straight line. So that means that must be the vertical asymptote right there. Okay. Plot the point on the curve 1 unit to the left or right. Well, the curve itself is on the right. Okay, so we got to go to the right, 1 unit to the right of the asymptote and down to the curve, so that's the point right there. Identify the base. To identify the base, we're either going to go 1 unit up or 1 unit down, but we want to be between the curve and the asymptote, so we're not going to go down. We want to go up, or between the asymptote and the curve all the way over here. So 1 unit up, then go to the asymptote first, then from there measure the distance to the curve, which is right here. That's a distance of 1, 2, 3, 4, 5. So it's a distance of 5. Whoops, there we go. So this is log base 5. So we're going to go f of x is equal to, we know that it's going to be log base 5. Okay. Then it says identify the left or the right shift based on the vertical asymptote, right? So the vertical asymptote is not here. It's over here to the left. So the distance between the vertical asymptote and the y-axis is -2. So that's a -2 shift. And so we're going to we know that somewhere in here we're going to have an x plus 2, right? Then it says identify the up or down shift based on how far the point is up or down from the x-axis. Well, here's the point, and here's the x-axis right here, so the distance from the x-axis down to the point, that's a -3 shift. So we know there's going to be a -3 on the end. Last thing, we got to put on negatives based on reflections. Well, vertically, it's going down, which is normal, and then it's on the right side and flattening out to the right, which is also normal, so we don't need any negatives at all. That makes this our final answer. f of x is log base 5 of x plus 2 minus 3. Notice we do not need extra parentheses because there's no negative. It's not backwards. There's no negative on the x plus 2. So the way I would key this into the computer would go like this. log underscore, that means base 5. So this is log base 5 parenthesis x plus 2 close parenthesis minus 3, and that would be the answer that I would enter in. Okay, let's try another example. All right, here's another example. If you want to, you can go ahead and pause the video and try and work through these 6 steps, and then I'll do it and you can see if you got the right answer. All right, so first thing I'm going to do, step 1, draw on the asymptote. I can see that the graph goes very steep. It goes perfectly vertical, or just about perfectly vertical, sorry, right here. And so there's my vertical asymptote. It appears perfectly vertical. Technically speaking, I know that it's not, but it appears perfectly vertical. Step 2, plot the point on the curve 1 unit left or right from the asymptote. Well, this curve is on the left side of the asymptote, so I'm going to go 1 unit to the left of the asymptote. I'm going to go up or down until I hit the curve. Boom, right there. 1 unit over from the asymptote. Good. Now I'm going to identify the base. So I'm either going to go up 1 unit or down 1 unit. I'm going to go up 1 unit because I'm now between the asymptote and the curve. And so now I'm going to go over to the asymptote right here and measure the distance from there over to the curve, which is right there. It's a little more than 2, but not quite 3. Or it's more than 2, but not quite 3, but it's closer to 3. That makes it e. Okay, so I know that this is going to be a natural log. F of x is equal to natural log, right? Now it says identify the left or right shift based on the vertical asymptote. Okay. Well, the vertical asymptote is here. The y-axis is all the way over here. Looks like the distance between the two. This distance is 1, 2, 3, 4, 5. And it's to the left. That's a -5 shift of the vertical asymptote. So that means that in parentheses we're going to have x plus 5. Right? Okay. Good. Now it says identify the up or down shift based on how far the point is up or down from the x-axis. Well, here's the point. Here's the x-axis. This distance right here, right? That's a plus 2. So the point is up 2 units. That's a plus 2 shift. So we're going to put a plus 2 on the end. And then lastly, it says put on negatives based on reflections. Well, it's not upside down because look, where it goes vertical, it's going down. That's normal, right? But it is on the left side of the vertical asymptote, and it's flattening out to the left. That means that this is backwards. This graph is backwards, so we're going to put a negative with the x, right? Well, but this says if it's backwards and there's a horizontal shift, there sure is, there's an x plus 5 horizontal shift, then you're going to need extra parentheses. So what I'm going to do here is I'm going to fix this up a little bit. I'm going to take out this x plus 5. I'm going to put in my parentheses for the logarithm. Then I'm going to put a negative. Then in more parentheses, that's where I'll put the x plus 5. And so what I have here is f of x is equal to the natural log of the negative of parenthesis x plus 5. Then on the very end, a plus 2 vertical shift, right? Now, I want to put this into the computer to get my answer so it's typed in correctly. And I would put ln, then open a parenthesis, then put a negative, then open another parenthesis, then put an x, then a plus, then a 5, then close a parenthesis, then close a parenthesis again, then put on a plus, and then a 2, and this would be the correct answer that I would enter into the computer. Okay? Let's try just a couple more examples. All right, so here we have another example. Do you want to try and pause it and try it out on your own? All right, now let me give it a shot. Let's check your work. I can see that it goes real steep and vertical right here at this vertical line. So I'm going to draw in my vertical asymptote right here. It says step 2, plot the point on the curve 1 unit to the left or the right. I'm going to go to the left because it looks like this curve is on the left side of the asymptote. So 1 unit to the left, go to where the curve is right here, plot a point. That is the point. Now I want to identify the base. All right, so the base, I'm going to go either up 1 unit or down 1 unit from this point. I'm going to go down 1 unit because that puts me between the curve and the asymptote. And then I'm going to go over to the asymptote right here, 1 unit, and then over to the asymptote. Then I'm going to draw all the way over to where the curve is, which is way over here. And what is that distance? 1, 2, 3, 4, 5, 6, 7. So this has a base of 7. Okay, so I know that this is going to be f of x equals log base 7. Okay. Step 4, identify the left or right shift that's based on the how far the vertical asymptote has shifted. All right, well, here's the vertical asymptote. Here's the y-axis. We can see that the distance is a +3 shift between the y-axis and the vertical asymptote. So that means that we're going to do an x minus 3, right? Because it says with opposite sign, right? So we know that this is going to have an x minus 3, okay? Then it says identify the up or down shift based on how far the point is from up or down from the x-axis. Well, here's the x-axis, and here's the point, so we're going to go vertically from the x-axis up. See what that distance is, 1, 2, 3, 4. That's a +4 shift vertically from the x-axis. That means we're going to have a +4 on the end of the logarithm. Last thing we're going to do here is we're going to put on negatives that are based on the reflections. Well, this has actually 2 reflections. You'll see that the steep part goes up instead of down. That means it's upside down. So we know we're going to put a negative on the front of the logarithm. Also, the curve is on the left side of the asymptote instead of the right side of the asymptote, which means that it's backwards. So we have to put a negative on the x minus 3. But remember, if it's backwards and we have a horizontal shift, we need an extra set of parentheses. So what I'm going to do here is I'm going to throw in here a negative, then an extra set of parentheses, and that's when I'll put in my x minus 3. Okay? And so I'll have negative log base 7 of the negative of quantity x minus 3, then +4. Okay? And when I put this in the computer, I can put it in as negative log underscore 7, right? Negative log base 7 of parenthesis, then a negative, then parenthesis, and then an x minus 3, close parenthesis, then a +4, and there we have, we can enter that in the computer, and this will be our correct answer, okay? All right, let's just do maybe 1 or 2 more examples. All right, here's another one. Your chance to shine on your own, unfortunately, but why don't you pause the video and see if you can figure this one out. All right, so first thing I'm going to do is I'm going to draw in the vertical asymptote. Looks like it goes vertical right about here, so there's my vertical asymptote. Draw right along there. Okay. Now I want to plot the point on the curve 1 unit to the left or the right. Well, the curve is on the right-hand side of the asymptote, so I'm going to go 1 unit to the right, go down to where the curve is. It's right there, so that is the point. Identify the base. To identify the base, I'm either going to go 1 unit up or 1 unit down. I'm going to go 1 unit down because that's where it opens up here, right? And so I'm going to go 1 unit down over to the asymptote, and then from here measure the distance over to the curve. All right, well, it's 1, 2, 3. It's not quite 3, but it is greater than 2, and it's closer to 3. That makes it e. So this has a base of e, so this can be a natural log. So we know it's going to be f of x is equal to natural log. Okay. All right, now we need to identify the left or the right shift. Well, here's the y-axis all the way over here, and here's the vertical asymptote. So the distance from here all the way over to here looks like it's, let's draw that line right there. It's from here 1, 2, 3, 4, 5, 6, 7 to the left. That's a -7 shift, right? So that means we're going to put on an x plus 7, right? So natural log of x plus 7 because we have to put on the opposite sign. Remember, whenever we put a shift with the x, a horizontal shift always gets an opposite sign. Then we're going to identify the up or down shift based on how far the point is from the x-axis. Here's the x-axis up here. Here's the point way down here. This distance from the x-axis all the way down to here, let's see, that's -1, -2, -3, -4, -5, -6. That's because it's down, so that's a -6 shift. So we're going to put a -6 on the end. Now we need to put negatives on based on the reflections. Well, this graph is pointing up. The vertical part is pointing up instead of down. Therefore, this is definitely upside down. But it is on the right side of the asymptote, which is normal. It's pointing off to the right. Okay, therefore, it is not backwards. So we're not going to put a negative with the x. Therefore, we do not need extra parentheses. We're just going to leave it as x plus 7 in the logarithm parentheses. But because it's upside down, we do need to put a negative on the natural logarithm. And now if we want to key this into a computer, we would put negative first, then ln, then a parenthesis, then an x plus 7, then close the parenthesis, then a minus 6. And this would be the equation, the function, or the logarithmic expression for this particular graph. Okay, I'd like to do just one more example. All right, folks, here's your final example for the graphs of logarithms. Do you want to pause the video and see if you can figure this one out on your own? All right, so it's hard to see where it goes vertical because of the picture I've been given, but I can sort of see that it's not, obviously it's not going vertical over there, so it must be going vertical over here. So it's kind of hard to see that it's going vertical here, but I can see it just for maybe one or two things. I can see that this is where the vertical asymptote is. So I'm going to go ahead and draw that in right there. Okay. All right, now I need to identify the point 1 unit over from the asymptote. The graph is on the left side, so I'm going to go 1 unit over, go to where the curve is. It's right there. That's the point, right? Then I'm going to identify the base. I want to go 1 unit up or down. I want to go up because that's where, where I'm between the asymptote and the curve. So I'm going to go over to the asymptote right here and measure the distance to the curve, which is right here. It's 2. So this has a base of 2. So this one is going to be f of x is equal to log base 2, right? Now I want to identify the left or the right shift. Here's the y-axis. Here's the vertical asymptote. The distance between the two looks like a +3 shift. Okay, so that means I'm going to reverse the sign. -3. It's going to go along with the x. It's going to be x minus 3. Vertical shift, up or down shift based on how far the point is from the x-axis. X-axis is way down here. Looks like the distance here is going up from the x-axis. 1, 2, 3, 4, 5. That's a +5 shift. So we're going to put a +5 on the end. Last thing we're going to do is put on the negatives based on the reflections. Vertical is going down, so that's normal. The curve is on the left side of the asymptote. That is not normal. That is backwards, and therefore this is going to get a negative on the x. It's backwards, and it has a horizontal shift, so it's going to need extra parentheses. So here, my x minus 3, I'm going to put a negative, then parenthesis, then x minus 3 inside extra parentheses, and this is the equation of this. This is the function that goes along with this particular graph. If I want to put it in the calculator, or not the calculator, well, actually you could do it with the calculator too, but if I wanted to put it in a computer, I would write log, then an underscore for base, then a 2, log base 2, parenthesis, negative, parenthesis, x minus 3, close parenthesis again, then a +5. Okay, get rid of that. Okay, and this is what you would key in, and that would represent this expression as the function of this graph, and that is it. Okay, you should get plenty of practice on the quiz. If you have any questions, go ahead and send me a message, and we'll see if we can help you. But other than that, I hope you understand this. I hope you do great, and good luck.